Okay, so now we have covered the theory behind how our slide is going to work, and in this video, Lee is going to handle the implementation of that into the TP motor class. So Lee, whenever you're ready, man.
Alright, let's start off by adding some more public fields. The first one will be our slide threshold. We'll set it to 0.6F for a default. Well, how about 6 instead of 5? The next one will be another public float. This one will be max controllable slide magnitude. We'll set this to a value of 0.4F for default. We need to make a private slide direction. And this is going to be a vector 3 because it's a direction. That will be the fields that we're going to need to implement our slide.
Okay.
So we'll go down to where apply gravity is, and right after it we're going to add a new field or method. We'll call this apply slide. Put our brackets in. Now, as we said before, the very first thing we have to do is make sure that our character is on the ground. If our character is in the air, we don't need to do any of this. So we'll do if TP controller, we're going to look for its static reference to character controller, check to see if it's grounded. If it isn't grounded, so not grounded, we're going to return. There's no point in going any further or doing anything else if we're in the air.
Right. You can't slide in the air.
Now, if we are on the ground, the very first thing we're going to do is take that slide direction and we're going to zero it out. So we'll do vector 3, 0. We need to create, the next part is to create that raycast hit to hold our information from our raycast. So we'll take a raycast hit. We're going to create a field called hit info. That will hold our information that comes back from our raycast.
All right.
We're going to cast our ray, and we're going to see if we hit anything.
I do want to throw this out. That raycast hit is that structure we mentioned that is going to hold all of the information about the object we hit. Really, a lot of data about the raycast action in general.
Right. What we're going to do is now we got to cast that ray. So to do that, we're going to leverage the functionality built into the physics class called raycast. Now, raycast has a whole bunch of overloads. The one we care about is basically going to give it a position, tell it a direction, and then we're going to give it our structure, our hit info structure, and tell it to put all of our information about the hit into that and give it back to us.
Okay.
So we're going to start off with our position. To get our position, we're going to take our transform.position. Now we mentioned we want to offset it 1 unit up into the air. To do that, we're going to add a vector3.up. This is a vector that is in the upwards direction that is 1 unit tall.
Right. It's equal literally to 0, 1, 0.
Right.
Which will move this up by 1 unit.
Right. And we need to give it a direction, so we can also leverage vector3.down. Which is a vector pointing down.
It's just the first time we use it, when we call on up, we're defining a position.
Right.
Second time when we call down, we're now defining a direction, which is going to aim this ray straight down.
Right. And that vector basically looks like 0, -1, 0.
Right.
Now, we also need to give it the hit information. And because we want to give it the hit info or the hit information structure that it's going to pass back out, we got to tell it that we want something back out, so we give it the out keyword, and then we say hit info. So now we're telling it, all right, save the hit information inside of this structure and give it back to us.
Okay.
So if we hit something, we need to do something. What we're going to do is check to see if our normal that gets returned is less than our threshold. So to do that, we do another if hit info dot normal dot y is less than our slide threshold, meaning the y component, the angle or of that normal is at a steeper angle than our threshold allows, we need to slide. So that's what that comparison does. If that case is true, we're actually on a steeper slope than our slide threshold, we need to set our slide direction. So we're going to say slide direction is going to equal a new vector 3. What we pass into it is going to be our hit info dot normal dot x. Same with hit info for our y, normal dot y. But because we want to slide down and not up, we need to invert the y component of our normal.
All right.
And then we're going to take the z of our normal and put it into the z component of our slide direction. That will build our slide direction for sliding.
Okay.
Now, that all happens if we've slid, or if our normal y is less than slide threshold.
Right.
The next part of that is we have to look at our slide direction and check its magnitude. If our magnitude is less than our max controllable slide magnitude, then we're going to allow some control with our slide.
Okay.
If we're above that, all we can do is slide. To accomplish that, we're going to do if slide direction dot magnitude is less than our max controllable slide magnitude, then go ahead and set our move vector to be plus equals our slide direction. So what we're doing is we're taking our move vector, which has all of our movement information that we've processed up to this point, and we're going to add our slide direction or our slide movement to it. Now, if we're greater than, so else, because this was less than slide magnitude, so if it's not less than slide magnitude, we must be greater than it or equal to it. So if we're greater than or equal to our slide magnitude, all we can do is slide. So we set move vector to equal our slide direction.
Yeah.
So now all we can do is slide. Now we've got our apply slide method coded out. We need to actually call it to have it work. Now, where we place this is kind of important. If we place it too late or after apply gravity, our slide direction is going to be a vector.
Right, it'll be modified.
Right, which will only be roughly a vector of 1. So we need to have our vector applied by our move speed as well. So we need to check our slide before we multiply by move speed. So we have to place it up here.
Okay.
So what we're going to do here is we're going to apply sliding if applicable. And to do that, we just call apply slide. Apply slide will determine whether or not we have to apply slide.
Right.
Did I spell something wrong again?
No, you did fine. I was kind of smirking at apply sliding if applicable. If we can apply it, we will apply it.
Yep.
It works. It works.
So let's build it out, see if we have any errors. Doesn't report to have any errors. Now let's go play with it inside of Unity. So give it a sec and we hit play. So here's our character. If I select him, here's our slide threshold, here's our max controllable slide magnitude. So we should be able to still move up. Now let's see what happens if I go step on this guy. So our threshold isn't low enough to prevent, so we can't move up, but we can move down. We're not sliding.
Okay.
And we can't move up because our character controller has a slope limit.
Right.
So let's go modify our slide threshold some more. Let's try, say, 0.4.
Okay.
So now let's try climbing up this one. Yep, we're still good enough. We can climb up that one. What about this one? Yep, we're still good. Let's try the other way. Let's try 0.8. So we're still good here. Let's go over here. Uh-oh.
Now we're sliding.
Now we're sliding.
Okay.
So now, if we take our slide threshold and we bump it up again, let's try 9. Or 0.9. Oh, I can't even get up this one anymore.
Gotcha.
but I can jump because we got a lot of jump. But as soon as I hit this, we start sliding down.
Yeah.
So our threshold is now set high enough that we can't climb up either of these. Well, this one we can kind of force our way up because our magnitude is still enough that we still have some controllable ability on it. Now this one, if we check, it's greater than our max controllable threshold, so we can't move up it.
Right.
It's forcing us down regardless. This one we can still fight because we're less than magnitude. This one, because we're greater, we can't really get back up it.
Gotcha. Okay. So at this point, we've got our slide threshold, our max controllable slide. Those are both been implemented. Of course, we have some sliding behavior taking place in the character now. And with that, we are ready to move on to the next stage in our process. That's going to wrap things up for this video. Thanks a lot.